Hello everybody, this is an educational video for demonstration of a few concepts in medical embryology. This project was prepared by Sami Ghazali, Mahran Ode, Yahya Hambali, Lu'ay Akir, Haytham Musmar and Wasif Sayh, second year medical students at An-Najah University. We as students would like to show our heartfelt gratitude to our Professor Malik Sabuba, who inspired us infinitely during the medical embryology course. We hope you will enjoy and understand the ideas performed. The first concept that we would like to describe is the lateral foldings of the body wall of the embryo. This concept will be explained by Mahran Ode, Lu'ay Akir and Sami Ghazali. Now speaking is your classmate Mahran Ode. To start with, this process occurs between the middle of the third week and the end of the fourth week, which means a duration of 10 days. To be oriented, this is a transverse section showing the stage of the trilaminar germ disc. The blue color is the ectoderm, the green color is the amnion, which is continuous with the ectoderm, or which is the continuation of the ectoderm. The red color is the mesoderm. The yellow color is the endoderm. And you can notice the black spot, which represents the notochord. Before jumping to the process of the lateral foldings of the body wall of the embryo, we have to discuss another process, which is neurulation. Neurulation occurs or starts before the lateral foldings of the body. Neurulation, as we all know, means the formation of the neural tube. As you see here, by the end of the third week, the lateral edges of the neural plate become elevated to form the neural folds, and the depression mid-region forms the neural groove. Gradually, the neural folds continue to be elevated and gradually fuse in the midline with each other. When the fusion is complete, as you see in this picture, the neural tube is formed. Now, my classmate Lu'ay Akir will continue with you in order to explain the process of the lateral folding of the body wall of the embryo.
Hello everybody, this is Lu'ay Akir talking. I will explain to you how the lateral folds of the body will form. Initially, in the 17th day, a part of the mesoderm called lateral plate mesoderm splits into parietal and visceral mesoderm layers. The parietal layer is adjacent to the surface ectoderm and continuous with the extra-embryonic parietal mesoderm layer over the amnion. The visceral layer is adjacent to the endoderm, forming the gut tube, and continuous with the visceral layer extra-embryonic mesoderm covering the yolk sac. As you can see, they are red in color. Next, the mesoderm parietal layer, which overlies the ectoderm, will form the lateral fold of the body. These folds will move ventrally. Eventually, they will close the ventral body wall in the midline, except at the connection of the gut tube with the yolk sac. As you can see, during that, the endoderm will be thinner to form the gut tube. This is yellow in color. This is the end of my presentation, and I would like to make special thanks to my colleague Sami Ghazale, who was playing with the clay during our explanations. This is the part of the foregut that will dilate and form the stomach. The left side of the tube is the white part with the left vagus nerve appears on its surface, whose color is yellow. The right side of the tube is the black half with the right vagus nerve appears on its surface, whose color is also yellow. The mesentery also appears in this video. The mesentery is attached to the posterior abdominal wall and called the dorsal mesogastrium. The mesentery is also attached to the ventral abdominal wall and called the ventral mesogastrium. Now we will explain the rotation of the stomach tube. The tube now is rotating along its longitudinal axis 90 degrees clockwise. The left side, which is the white half, becomes the anterior surface with the left vagus nerve on its ventral aspect. The right side, which is the black half, becomes the posterior surface with the right vagus nerve on its dorsal aspect. The dorsal mesogastrium will move to the left side of the abdominal cavity due to this rotation, and the ventral mesogastrium will move to the right side as a result of this rotation.
Hello everybody, I am Haytham Smart and I'll continue to explain the rotation of the stomach around its anterior-posterior axis. The stomach starts to rotate around its anterior-posterior axis clockwise. Simultaneously, the original posterior wall grows faster than the anterior wall, forming the greater and lesser curvatures. Now we remove the mesentery. The stomach takes its final shape when the pylorus moves upward to the right and to the cephalic portion to the left and slightly downward.